Hello, everyone. So my name is Kevin Liu, and I've done FLL for 3 years from 2017 to 2019. And today I'll be exploring programming with Lego Spike Prime. And Spike is sort of an in-between of WeDo and EV3, and it's sort of a way to bridge the gap in difficulty between the two products. So yeah, I'll be diving into some of the basic motor control movement. I'll show you how to program motors, how to move from one place to another. And near the end, I'll also introduce some sensors, including force and distance. So let's get started. All right, so I'll first begin by sharing my screen. And to program the LEGO Education Spike Prime, we need to download an application, and it is found on the LEGO website. So first we click Start to create a new program. Afterwards, we click Start Here or Home, Start Here. And now we have a blank screen with code. So there's a sort of introduction, and there's lots of lessons that the Spike Prime app also provides you. So the first step is, if you see the robot in the other camera, first step is to hold on the power button and turn it on. And for our programming session, we'll be using Bluetooth. So to make sure Bluetooth is turned on, there's a Bluetooth button on the robot, and I just click on that. And on my screen, I can click Connect to Hub, connect via Bluetooth, and it senses this hub, so all I have to do is click Connect. So now my computer is connected to the robot, and I can program it from my computer, and I can run it from my computer. So we'll first begin by creating a new project, and this app provides two methods of programming, and the first is one called word blocks, which is the one we'll be using, but another alternative is Python, which might be more similar to the coding languages that you've seen. But the word blocks are similar to Scratch if you've done that before, and they're a lot more beginner friendly than the EV3 Mindstorms. All right, so we'll first explore motor movement. And on the robot, there will be a bunch of ports. And let me show you over here. There are 6 ports labeled A, B, C, D, E, and F. And for our robot over here, the movement motors, which are the ones that, these big wheels that drive the robot forward, on our robot, they're connected to the ports C and D. So what we can do first to begin is to set our movement motors to C and D. So notice that we can run the program with this run button, play button over here. So if we click on that, and you'll hear a short sound played from the robot, but nothing happens because all we've done in this program is set the movement motors to C and D, but we haven't actually told it to move. So now the question comes, how can we make the robot actually move? So the commands here, including move forward for 10 centimeters, move in a direction for 10 centimeters, and start moving and stop moving, these are the ones that control the movement motors. And the ones here, like setting speed to 50, setting one motor rotation, which I'll talk about later, these are simply settings. They don't actually move the robot forwards or backwards. So let's just drag one of these real quick and see what happens. So all I have to do is click on this play button over here. and you'll see that the robot moves forward and it actually fell down a bit. So this block, which is just a move forward with the movement motors, there are a few settings that you can change for this. So the first is just then we used centimeters. So we told the robot to move forward for 10 centimeters. However, instead of centimeters, you can also use other units of measurement, including seconds. There's inches, rotations, and degrees. So inches is just another form of measurement. Seconds, you'll probably understand, but rotations and degrees might seem a bit confusing at first. So rotations is the number of times the wheel spins. So if the wheel spins a full revolution, that would be 1 rotation. And degrees is just the degree of how much the motor has moved. So it would be 360 degrees multiplied by the rotation. So if you can see, if instead we move for 2 seconds, and we run that, the robot moves quite longer since 2 seconds is pretty long. So that's it for changing these values over here. But if you see that little drop down over here, there are also more values that you can change. So this one, in this block over here, we can change the direction of the movement. So we can go forwards, we could go backwards, we could turn, we could left turn, right turn. So let's just try moving backwards for now. I'll move the robot forward. So let's say 5 centimeters. So if we run this, you see that the robot moves towards me for 5 centimeters. And another really similar block is this one right here. So if you compare the two, both of them move straight and both of them move forward for 10 centimeters. So in this case, they would do the exact same thing. But the cool thing about this block is that you can change this, how much you steer. So for example, if I want to steer towards the right at a 30-degree angle for 10 centimeters, then let's see what happens. Then it sort of veers to the right, like we programmed it to. And the final part for moving movement motors is this block called start moving. And unlike these two blocks where you specified a distance, a time, a rotation degree, this one, all you're telling it to do is just move straight. So let's run this first and try to guess what will happen. Okay, so I click the play button and the robot keeps moving forward and it doesn't stop moving forward. It's still moving forward and I'll have to stop it manually. So, oops. So let me stop this robot first. So the first thing you notice is this actually makes sense given our code, because all we've done when the program starts, we set the movement motors to C and D. So these motors, these commands, these blocks are going to affect the motors C and D. And then we've told the program, the robot, to just start moving straight. But we've never told it to stop. So if we put a stop right after it and we play this, then nothing happens because we've told it to start moving forward, it'll start moving forward, but then we immediately tell it to stop. So if it starts moving forward but immediately stops, then it just won't move. Like, for example, if I run the program, the robot just will stay in place. So instead of that, you could also use this in other ways. So for example, if in between these two blocks, we put a wait block, and all this wait block does is when the program comes to this wait block, it'll wait for how many ever seconds you tell it to wait for. So let's say we want the robot to wait for 3 seconds before stopping. So what will happen in this case? So let's run the program to find out. So basically, the robot started moving, and it moved for 1 second until it was told to stop. So it stops moving after 1 second. And the other commands are where we can set the movement speed. And this could be useful when you're not trying to go really fast. So let's say if we set it to 10, and perhaps we let it run for a second, then okay, so 10 was a bit slow. Sorry about that. Oh, I think it was because I took out the movement motors. So if we run this again, making sure that our movement motors are set to C and D, we'll see that it only moves a tiny bit and quite slowly. So that's what happens when you change the movement speed. And finally, setting the motor rotation is like we said earlier, where you can define how much a motor rotation is equal to inside of these blocks. Okay, so now we've explored movement motors. So now we'll turn to these sort of other motors that don't make the robot move back and forward or turn, but they do other cool stuff. Okay, so in our robot, there are 3 main motors. Like we explored earlier, motors in the ports C and D. Here. Motors in the port C and D are the ones that control movement, and they determine how the robot moves forwards, backwards, sideways. But on a robot, we also have another motor, and that controls this arm over here. And you see how this arm can move up and down. So in contrast to these movement motors that are controlled by one of these smaller motors, this arm over here, I'll show you again. This arm here is controlled by a large motor, and it's called a large motor because the large motor is larger than the 2 other motors. So unfortunately, we can't use these movement blocks to control a large motor, but instead the large motor has its own blocks, and you can find them in these blue, the motors blocks. So first, so just like before, there are some blocks or code that make the actual motor move. And there are some other ones that set the settings of the motor, such as setting the speed. In addition, there are 2 other parts that we didn't see in the movement, but we'll get to these blocks later, and they're a bit more complicated. So first, we can let's just see what happens when we run this program. So if you saw that, the robot actually turned instead of what we wanted it to do, which was to move its arm. And try to take a look at this code and see what's wrong with it. So actually, our robot turned, the movement motors turned instead of this large motor because this motor wasn't on C, it was on E. So when we told motor C to run, the robot turned like it was supposed to, like we told it to. But instead we wanted E to move, which was this arm. So if we run this again, you see that the robot lifts its arm up. And that was this direction, but you could also go in the reverse direction. So let's just run that. So in this case, the motor falls back to where it was before. And that's how you can control these motors. In addition, there are also some similar commands such as start motor, where you just tell the motor to keep moving. And if you run this, sorry, and I made another mistake. I made a mistake by not changing this C motor to E. So if I change it to E, then the arm should lift up. Yeah, but now you see how the arm just continuously lifts up and it never stops. And just like before, we have to have this stop motor and perhaps some sort of pause in between where we wait for a second, let's say. So I'll just reverse the direction so we can see the movement. So if we run this program, we can see that the motor moves down. And a tip I have for using these motors is to always use seconds. And what I mean by that is when you use these motors and you move them, you can see how you can set them for rotations, degrees. Let's say we set it for 100 degrees. Then the motor will move that corresponding amount. But my recommendation is to always use seconds. And this is because oftentimes this arm will become jammed. So if you tell it to wait, if you tell it to move for, let's say, 5 rotations, then it will keep moving until it reaches 5 rotations, even if it is jammed. But if it's jammed, it's stuck, it can't keep moving. So then this code will run for an infinite amount of time. And that's not what you want. So instead, with seconds, even if it's jammed, this code, this block will just stop running at 5 seconds. So that's it for these motors. And now we'll have some bit of fun with some practice movements. Okay, so now with the knowledge that we've learned of motors and movement motors, let's first try a problem involving movement. So here, I'll show you the problem. So, and you could do this in your homes as well. So pick a point A, and let's say this is the point A. Pick a point A and pick a point B. So that's the point B. And your goal is to write code so that your robot can get from point A to point B. So which blocks do you think we would use first? Should we use the motor blocks, which control the arm, or should we use the movement blocks, which control the wheels? Well, to get from A to B, we need to move with the wheels. So we would probably use the movement blocks. So if we just take a movement block and just run it, sorry, and once again, you have to remember to set the movement motors to whatever port the motors are connected to. And in my case, they're C and D. So running this one more time, you'll see that it moves forwards. But unfortunately, the surface on this table isn't too good. So, and you see how it tips over a bit. So for me, I'll just set the movement speed to something slower. So let's try that again. And keep in mind that we're trying to reach this point B. So you'll see that this is still not too far. And we could just keep experimentally trying this, and that would also work. So let's just first try this out experimentally. So we know that 10 is 2 less. It still hasn't reached this line that the box is on. So if we say 20, for example, and we'll just try to get as close to the number as we can. And remember to, sorry, I made that mistake. We need to remember to start at the same place every time. A consistent starting is always important. So if we start here and move 20 centimeters, we'll see that, yeah, we're just about there. And if we turn right, then we'll get there. So, okay, so that's one way to figure out how to move forwards. But another way, since you can program it with centimeters, you can always just take a ruler and measure how much distance it is. So if we put this point here, and from a starting point, yeah, we'll see that it is about 20 to 30 centimeters, sorry. So our next step, once we reach there to get to point B, we need to turn. And there are two ways to turn. We can turn with one of these two blocks, like this or like this, or we could just tell a single motor to turn. And initially, I showed you how these blocks, these motor blocks, could be used to control the claw on the robot. But that's not all they can do. They can also, these motor blocks can be used for any motor, including the wheels. So if I tell the robot to move C, the motor C on the robot, then it will turn. So we have to first figure out which motor is which. If is the left motor the C or is the right motor the C? So let's say we just move C for one rotation, and we'll see which one it is. So the left motor moved for one rotation, so we know that the left motor is C. So, but instead over here we want to move the right motor, and it's reversed on the screen in the video, but for this wheel on this side, we want to move this wheel like that, so it faces the block and can reach. So we move forward and we want to turn our motor, E, and let's just say one rotation for now, or maybe degrees, it's equivalent. So starting here again, the robot first moves forward, and then, oh yeah, sorry. It's because 1 degrees is a very, very small amount. If you remember, one rotation is 360 degrees. So maybe we could try 360 degrees to begin with. And let's start back here. Starting back here. So we first move the robot. The robot moves forward, and then it turns. Oh, sorry. Yeah, it should be motor D. And when you look at this model over here, you can actually see and figure out which motor is which. On A and F, you have two sensors, which I'll talk about in a bit. But on C and D, you can see how these motors, called medium motors, are smaller than that larger motor, which is known as a large motor. So instead of E, that should be D. So if we run this again, whoa, okay, so that was a tiny bit fast, and it sort of shook a robot a bit. And that's where this speed setting comes into use, because oftentimes the faster you are, the less accurate you get. So let's just say we set the speed to 30. And remember that it's motor D. And looking at that, it seems that the robot overturned a bit. So oftentimes it's a lot about adjusting values. So let's just say 200, and we'll probably have to adjust it more. So starting again here and running the program. And just a tiny bit too less, so maybe 250 we could try, or actually 235. We're all just guessing values, and there's no really accurate formula to calculate. So let's run this one more time. Okay, so that was actually quite close. Maybe it was a bit off because if we move forward, we don't really reach the block. So let's say we move forward for 25 centimeters. So the next step, so right now we're over here and we're trying to get a robot to point B. So now it's a lot simpler. To get a robot from point A to B, all we have to do is move forward. So let's just say I move forward for 10 centimeters and we'll see how far that is. So I start the program and it moves forward, it turns, and it comes just in range. So perhaps we can make it move, let's say 13 centimeters. And at this point, we would be pretty close. For example, if you were doing an FLL mission and maybe you were trying to collect some object over there, this could be a common way of trying to solve that problem by testing values and yeah, just running. Okay, just running the program again. We turn. And now we're perfectly there. So now we've achieved our goal of trying to get from point A to point B. So the next step in upgraded challenge is to try to capture this block with this medium motor, this arm over here. So, okay, so currently our program gets us to that point, but our next step is to use our claws, use this claw to actually capture that Lego brick. So remember that we can move our claws with these motor commands. And my recommendation, like I said before, is to use seconds. So let's use seconds and see how that works out. So I'll run that. So it turns, it moves forward. But something weird happened. So whenever something weird happens, you probably want to take a look at your code. And in my case, instead of moving this way, I should have actually made it move the opposite way so that the arm moves down. So the robot runs. Once again, it moves forward. It turns. And oh, unfortunately, it slightly misses it. But it's close. It's pretty close right now. So maybe we can make it move 14.5 and for 1.5 seconds. Let me just take a look here. Unfortunately, it seems that the balance of this robot isn't the best, so it might be a bit difficult to sort of grab this block. Okay, I can still try. So, and remember to reset this claw back to its original height. So here we are once again. We make the robot move forward, turn, and catch the block. And if it was a bit more like that, we could just move back. But yeah, you should be able to, as an additional challenge, you can try to move back to base, back to where you started. And that's also common in lots of missions tasks that you'll see, is to move out from base, move somewhere, do a job, and then move back to base. So yeah, you can try that part for yourself. And a hint is that you already have all the numbers that you need. And all you have to do is reverse these actions that you've done. So in our final section, I'll just introduce a bit about sensors that Lego Spike Prime uses. So on this robot, I'll bring it closer for you to see. on this robot, I have a force sensor and in EV3, Mindstorms, or NXT, and other Lego products, they're known as touch sensors. So this force or touch sensor over here, and similarly in Spike Prime, this is called a distance sensor, but more commonly you'll hear it known as the ultrasonic sensor. So the force sensor measures if you've touched it, and this could be useful for when you're trying to know if you've hit a wall or not. And I would say the ultrasonic sensor is probably one of the most useful ones because this measures the distance and it can tell you how far away you are from something. And the third sensor that Lego Spike Prime has is the color sensor. And the color sensor can sense the color that is in front of it. And unfortunately, I don't have the color sensor on this robot, but it works similarly to the other sensors in that you have these commands and other similar things. So we'll first explore the force sensor or touch sensor. So there are actually two ways of doing this. The first is a bit simpler. So we could do this by, so let's say we want to make a program where if we press the force sensor, the robot moves forward for 15 centimeters. So how we would do that is we start with a when program starts, but know that we don't always have to use this block. Instead, we could use something like when A is pressed. So, and this is perfectly what we want. So when A is pressed, when the force sensor is pressed, then all we have to do is move forward for 15 centimeters. So let's run that program. Here's the robot. So yeah, I've run the program. You might not know because nothing's happened, but if we press this force sensor, okay, so once again, and just then we had a problem here, which was when we press the force sensor, like the program says, when A is pressed, we move forward for 15 centimeters. So this doesn't really work. For example, when we run the program, click the sensor, nothing happens. So spend a few minutes and try to think of all the possibilities that could have gone wrong. So hopefully you've seen that we've forgotten to set the movement motors, and you have to know how important this is because if we don't set the movement motors and we simply tell the robot to move forward, the robot doesn't know which motors to move. It might understand the command to move two motors, but it doesn't know which two specifically motors. So when we use this block, we set the motors to C and D. So if we run this program, and I'll just press this force sensor, and you'll see that the robot suddenly moves off. And so that's it for when the force sensor. But another way of doing this, instead of using this block over here, is when the program starts, and this is one handy block, it's in the control section that you have, is the wait until. So this block, if included in your code, when the code comes to this block, it will just wait until whatever is in this condition. And if you see this sort of dark part, it means that it's missing one of these commands. For example, you can stick this block inside of that one. So wait until the color is red. But in our case, we're trying to say we wait until the force sensor is pressed, and then remember to set the movement motors, and then we move forward for 15 centimeters. So if we run this program, we get the exact same result. And often the wait until block is pretty important, and it's really useful as seen in this example. So the final sensor we'll be exploring today is the distance sensor or the ultrasonic sensor. So these two are a bit similar, except The difference is that the force sensor is only pressed or not pressed, but instead the ultrasonic sensor measures a distance or a number. So if we go to sensors, we'll see that instead of saying if F is pressed, we would see is F less than 15%, but more commonly we want to use centimeters. Or so, for example, let's say we want to make a program where a robot keeps moving forward until it sees something 10 centimeters in front of it. And this is pretty common in FLL tasks and missions, where instead of just basing your robot movements off of movement blocks, you can use your sensors to ensure that your movement is more accurate. So to do this problem where we keep moving, if we need to move, we'll have to use the movement motors. So we go back to this familiar section, movement, and we set the movement motors to C and D. And since we don't know how long we'll be moving for, we just tell it to start moving. And if we run this, the robot will just keep on moving. So now we have to add a part that checks for if there's anything in front of this ultrasonic sensor that's within 10 centimeters. So how we can do that is, just like before, we can pull this wait until block from the control, and it'll start moving, but once the distance sensor measures less than 10 centimeters, then we want it to stop. And going back to movement, there's that stop block. So hopefully what this program does is when it starts, it sets the movement motors to C and D. So we're telling the computer that the motors that we want to use for movement are C and D. Afterwards, it moves straight, but we don't specify distance. All we're telling it is that it moves straight. And finally, we just keep moving straight until it's within 10 centimeters of something, the ultrasonic sensor. And finally, once it sees something 10 centimeters within, it'll just stop moving. So let me just prepare something in front of it so that it might see something over here. So let me run the program. So theoretically, it should keep moving until it reaches around that point of the flag. Yeah, so it stopped perfectly. The ultrasonic sensor saw that there was something in front of it, and the robot stopped moving. So yeah, that will be it for this programming with Spike Prime. So in this section, we explored how to move with motors, and not only move, but change some of the settings such as speed and movement motors. And afterwards, we looked at another form of motors, but these motors move only one. And for example, if you wanted to move your claw that has the large motor, you would use these types of blocks instead. And finally, we saw there are a lot of control blocks, but we saw how we can use these, such as when the force sensor is pressed, and instead of using when program starts. And another important block that you'll often use is the wait. For example, if you just want to pause a bit, perhaps you're waiting for another motor to do something, or sorry, you're waiting for something else to happen, then you'll wait for a few seconds. And this is probably one of the most important blocks as well, is you're waiting until a specific action happens. So for example, we wait until A is pressed. And yeah, moving on to this section, you see you have all of these blue things. And you'll notice that all of these blue things are either true or false. So for example, if true, then something will happen. So we talked about that a bit. And yeah, in addition to all of those, there's also light. And on the Spike Prime, there's a sort of grid And let me bring the robots here. We didn't do any light manipulations, but a grid will actually light up and you can change how it looks on the spike prime. So that's the light. And there's also sound, which you can change and play with. And yeah, there's also operators and variables. Though those are more complicated, but often can be very useful. And finally, my blocks. And there are lots of tutorials online which explain more in depth. So yeah, I hope you enjoyed this workshop. And yeah, I can't wait to see you guys in first LEGO League. Bye.